This is a strange attractor. To be precise, it is the Halvorsen attractor. By the end of this tutorial though, you'll be able to simulate a whole bunch of chaotic attractors. While I won't be diving into the theory of chaotic systems, I would highly encourage you to explore the topic further. You see, strange attractors show us that order and chaos are not opposites. Chaos has hidden order, and that order has structure.
Anyways, let's jump right into the tutorial. Alright, so these are the three equations we will need to simulate the attractor. They take x, y, and z position values as parameters and an additional constant, which is a. Let's just ignore a for now and set up some initial points in space to provide the Halvorsen equations with position data. For that, I'm gonna grab a point gen pop and set the number of points to 300. If you convert this to a dat, you can clearly see that each point comes with its own set of XYZ position data in a 3D space. Cool. Since we will calculate new position data based on the initial one, we will need a place to store the newly calculated data. To do so, I'll grab a feedback pop and assign a keyboard in job to the start parameter. Alright, now we need a place for the attractor's logic. So let's grab a GLSL POP. I will add a pop to that and a pop to chop to get a better overview of what's happening. Pipe this into a null and drag it back on the feedback to initialize it. Okay, let's come to the fun part and write some code. So if you have no coding knowledge whatsoever, just try to follow precisely what I'm typing. I will also provide you with a link to the code on my GitHub in the description below, which includes detailed comments so you can study what's happening. Okie dokie, so let's start by setting up a function called Halvorsen that returns and also accepts a three-dimensional vector. Nice. Next thing I will do is basically bring the Halvorsen equation in GLSL context. Let's start with dx. We can basically copy the first equation. Px is the x-coordinate value of the past position, py the y, and pz the z value. Let's go ahead and do the same for the remaining two equations. Now the console tells us that a is not defined. So let's do this by heading to the vectors panel of the GLSL POP and define a as a float and assign a value of 1.5 to it. Nice. Now all we have to do is to actually make use of the Halvorsen function. For that I need to set up position variable, samples the position data from the past points in space, just like that. As for now, this position variable holds the data provided by the point gen we implemented previously. What we now need to do is actually perform the Halvorsen equations on these initial positions, thus changing the values the position variable holds. For that, we will just add the values that are returned by our Halvorsen function to the current position and multiply it by dt. We do that because we skipped dt in the function itself. At this point, we are almost done. The only thing missing is to actually set the positions of the actual points in space of our TouchDesigner context to reflect the ones we stored in the position variable. Just set PID to the position variable and we are done. As you might notice, the console now wants us to define TD as value. Let's do this in the vectors panel and assign a value of 0.005. As you can see, the points are in fact moving. Attach trail pop to that to better visualize the trajectories the particles travel and you are basically done. The rest is just playing around and experimenting. As always with TouchDesigner, the possibilities are endless. Break stuff, rebuild stuff, and most importantly, have fun. Anyways,
I would highly encourage you to explore the topic further. You see, strange attractors show us that order and chaos are not opposites. Chaos has hidden order, and that order is structure.